This is the lecture for section 3D, talking about index numbers like the CPI. An index number provides a simple way to compare measurements made at different times or in different places. The value at one particular time or place must be chosen as the reference value. And then we can use the formula here. We can calculate the index number by taking our value divided by the reference value and then timesing it by 100. Now, depending on what you're working with, they may round to different values. For our book, we are going to round them to one number after the decimal place. The following is a table of average gasoline prices for the following years: 1965, 1975, 85, 95, 2005, 2015, and 2020. And you can see then next is the price. And what they do then is they want to calculate the price index over here based on using 1985 as the reference value. So all of these were calculated taking the value in question divided by the 1985 value and then timesing that by 100. So you get 25.8, which is 25.8% of the 1985 value. And that means your price index is 25.8. And that is how they did this for every single one of them. Take the price in question divided by 1.2 and then times by 100. You should get 47.5. 1.2 divided by 1.2 times by 100 is going to give you 100. All the way down. You can go ahead and check that these last ones do give you the values on the right here, but I'm going to tell you it does work. Suppose the cost of gasoline today is $2.70 per gallon. Using the 1985 price as a reference value, find the price index for gasoline today. So in order to find the index number, we're going to take our current price divided by our reference value, which would be the 1985 price. So what I would have to do is I would have to go back to the table and see that the current price is 270, and then in 1985 that value was $1.20. So I'll take $2.70 divided by $1.20 and times that value by 100 and get 225.0. What that means is the current price is 225% of the 1985 price. Now, in more situations, we actually use the price index to determine what the price could be in the future, what the price was in the past. So, suppose it cost $16 to fill your gas tank in 1985. How much would it then cost to buy the same amount of gas in 2015? Well, if we go back to that table, the price index for 2015 is 210. And what that means is we have to pay 210% of the cost that it was in 1985. So we'll take 210% of that 1985 value, which was $16. 210% is the value 2.1 as a decimal. 2.1 times 16 means it would be $33.60 to fill that same car's gas tank in 2015. So the first three columns here are the table that we had previously for the price index of gasoline. The thing is, though, we can change the reference value, and that's going to then give us different price index values. So, depending on where our reference value is, we may have a different price index. So, you can see here, if we change this to now being 2005 as our price index, we're now going to take all of our original prices divided by $2.31 and then times that by 100, and that's going to then give us our price index here. So 31 cents was divided by 231 times 100 gives 13.4. I could take every single one of these divided by $2.31 times it by 100, and then you should get the price index over here for a reference value of 2005. Now let's say we want to use the 2005 price as the reference value. Find the price index if today's gasoline price is $2.70 per gallon. And we're going to compare that to the answer we got back in example 1, where we used 1985 as the reference value. So today's price is $2.70. We're going to divide that by 2005's price, which is $2.31 a gallon, times it by 100. And our price index will be 116.9. Now, we didn't get the same answer. The first one, when we did the example, gave us 225. This one gave us 116.9. And that should make sense. We should get a different value because we used a different year as a reference value. If I go further back in time, I'm going to have to increase that more than if I was closer to the current time period. So it makes sense that 2005 price index is only 116.9% of the price that we looked at versus going all the way back to 1985. That should be a bigger difference because prices were a lot less then. So I'm going to need to increase that a lot more than if I was looking only a few years back. So we get to the point where we now have what's called the Consumer Price Index. This is called the CPI. And rather than just looking at one item at a time and calculating the price index, we look at an average of more than 60,000 goods, services, housing costs, and things like that to be able to create a general price index to represent everything that we use. So we will talk about that CPI. And then the next thing we can talk about is the rate of inflation. And basically, this is just telling us how much did that CPI change relatively from one year to the next. So basically, going back and finding that percent change that we did earlier in chapter 3. This is a table for the Consumer Price Index for every year starting at 1981 up to 2020. And we are going to refer back to this table to answer a few example problems. Suppose you needed $40,000 to maintain a particular standard of living in the year 2014. How much would you need to have in 2020 to maintain the same standard of living? We're going to assume that the average prices of your typical purchase has risen at the same rate as the Consumer Price Index. So in order to do this, we first need to find the CPI change from 2014 to 2020. So what I'm going to do is I'm going to take the CPI for 2020 and divide that by the CPI of 2014. It's always what we have compared to our reference value going back to 2014. So on the previous slide, if we looked at 2020, the CPI would be 258.8, and for 2014 would be 236.7. So we're just going to divide those two numbers together and get 1.093. We're going to use that on the next slide to finish solving the rest of this problem. So the value we just found on the previous slide, 1.093, means that prices in 2020 are 1.093 times those values in 2014. So if we needed $40,000 in 2014 and we want to get to 2020, we're going to take this value, 1.093, times the amount of money we needed to figure out that in 2020, the same amount of money, $40,000 in 2014, we would need $43,720 to represent that same standard of living in 2020. As we mentioned a few slides ago, inflation can be calculated from our CPI. So we can determine the rate of inflation from the year 2019 to 2020 using the relative change formula, percent change formula that we did earlier in this chapter. So if we want to know 2019 to 2020, I'm going to take the CPI for 2020 minus the CPI of 2019 divided by 2019, which is what we started. So 258.8 minus 255.7. Again, these values are from the table back on slide 11. Divided by 255.7 is going to give us 0.01212. Again, we can times that by 100 to turn it into the percent. So our percent rate of inflation was 1.2%. And those values change. You'll see that in some cases, maybe inflation is 3%, maybe it's less than that. But in this case, it is actually a much less rate of inflation than was back in the late 1980s. This slide is going to basically turn that cost of living example into a formula. If we want to figure out how much something costs in a different year, knowing the CPIs, we're going to use the following formula. So if we want to find the price in some year Y, we will take the price in the year we know times the CPI of the year we want to go to divided by the CPI of the current year's price. And that is exactly what we did back on the cost of living example. We took the price, which was $40,000. We times by the CPI in the year 2020. CPI divided by the 2014 CPI. And this value was from 2014, and it gave us the price for 2020. So we will use that formula here to do an example with baseball salaries. In 1987, the mean or the average salary for a Major League Baseball player was $412,000. In 2020, it was $4,430,000. Let's compare those two salaries in terms of 2020 dollars and talk about how does the rise in baseball salaries compare to the overall rise in prices with inflation. So the first thing we're going to do is take that 1987 salary and determine how much it should have gone up based on inflation and consumer price index. So predict the value for 2020 based off of the 1987 value of 412,000. Then we're going to take the CPI from 2020. Again, go back to that table, reference it on slide 11, 258.8 divided by the CPI for 1987 is 113.6. So based on just inflation rates, we would have projected a 2020 salary of $939,000. Now, as you can see, that is definitely not the value that we are currently paying baseball players. So we're going to discuss that a little bit more here on the next slide. So what we calculated was a salary of $412,000 in the year 1987 would be equivalent to a salary of $939,000 in 2020. The actual salary is $4,430,000, and that's about 5 times what it would be just based on inflation. So clearly baseball salaries have not risen. They have not risen at the same rate as inflation. They have clearly gone above and beyond what inflation would have done. All right, so this example here, I'm going to change this value here to 1981. If someone needed $25,000 a year to live in 1981, how much would they need to have in the year 2020? Okay, so to predict 2020, I'm going to take the 1981 value of $25,000. I'm going to times by the CPI from the year 2020, which was 258.8, divided by the CPI from 1981, which is 90.9. And if I multiply those in a calculator, just exactly as you see it, 25,000 times 258.8 divided by 90.9, you should get $71,177.12. cents. If a movie ticket costs $20 in 2020, how much did it cost in 1990? So we were going to use our $20 that we have times by our CPI of 1990. So this one's going to go first. If I look at that table, it's 130.7 divided by the CPI for 2020. That's at 258.8. And this is going to give me $10.10 for a movie ticket back in 1990. According to the College Board, the average tuition and fees at a private four-year college and university increased from $8,396 in 1990 to $37,650 in 2020. Calculate the relative change and compare that to the CPI. Well, relative change wants us to take the difference between the two divided by the initial value that we had. So 37,650 minus 8,396. I'm going to take that result and divide by the year I started with, 8,396. If I do that, I'm going to get 3.48, which I'm going to multiply by 100 to get a CPI value, relative change value here, of 348. So if I go and look at the CPIs, the actual CPIs, to figure out how much of a change we have. So we're saying tuition rose 348% between 1990 and 2020. Well, let's look at the CPIs. So the CPI for 2020, 258.8. The CPI for 1990 is 130.7. Let's divide that by that initial CPI of 130.7. This is going to give me 0.98, which is times 100, or 98% increase. So according to CPI, it should have only increased about 98%. What actually happened is we increased by 348%. And what the result is, this is clearly much higher of an increase than would have been expected from our CPI. So the last thing I'm going to show you here is a website that can be used to actually calculate the inflation, or how much a certain amount in one year is in another year. So I'm going to open up this website and I will show you that here on a quick little video. So here is the CPI inflation calculator that is in the PowerPoint. And the first question says, if you have $100 in 1980, has the same buying power as how much in 2009? So the way we're going to do this is, first you want to make sure that the months are set to be the same, because we want to compare month to month, year to year. So I have $100 and I want to compare that was in 1980. I'm going to scroll and find 1980 here. $100 in 1980 has the same buying power as how much in January 2009? I'm going to click calculate, and it is saying that if I had $100 in 1980, I would need to have $271.39 today. The second question on our slide says we have $10 in the year 2009. $10 in the year 2009 has the same buying power as how much in 1920? We're going to go way back here, find 1920, and click compute. So $10 in 2009 would have been the same as 91 cents back in the year 1920. So you can use this website to help calculate how much a value was in one year to another year.